In this class, we'll be focusing on some of arithmetic progression. In arithmetic progression, we all know that arithmetic progression has a common difference between every terms that follows one another. That is, the common difference between each successive terms are equal to one another. And the elements that we have in arithmetic progression that we always consider when we are trying to solve any question as regard arithmetic progression are the first term, which is given the A as a letter that represents it, the first term. We have the D, which is a common difference. And we also have what we call the N, that is number of terms that is in question. Now, this set of elements that are found in the so-called nth term of arithmetic progression, they are also available in the sum of arithmetic progression. In other words, we are going to now, I'm not going to show you the formula that we used to employ when we are making use of when we are trying to solve a question as regard arithmetic progression. The formula is this: sum of arithmetic progression, that's sum of the nth term. This means sum of nth term is equal to n over 2 into bracket 2a plus n minus 1 into bracket of d, close the square bracket. But this is the formula that we normally make use of when we are trying to solve the sum of arithmetic progression. In this class, we are going to see some questions that we are going to make use of these formulas for, and we also look at the how to solve the so-called method of solving arithmetic progression, sum of arithmetic progression, making use of simultaneous equation. There are some questions that will lead to simultaneous equation. Let's look at how we are going to solve it one after the other. The question we have here asks us to find the 25th term of this term of arithmetic progression. Now, for us to solve this question, we have the value of our first term there. Our A, according to what is given to us, is 5 whole number 1 over 2. After we have gotten our A, we also need to find our common difference. The common difference will either be the second term minus the first term, or the third term minus the second term. In other words, the value we must get from the two of them must be the same value. So let's try to check the two together right now. Let's assume we are making use of the second term now, which is 4 minus the first term is 11 over 2. Let's find it out. This is 2, 4, 1 here. 1 into 2, 2 times 4, 8 minus, that is 11. That's what? Minus 3 over 2. That is when we make use of the second term, the first term subtracted from the second term. So let's now look at the second term subtracted from the third term now, which is going to be equal to 2 whole number 1 over 2 minus 4, which is equal to 5 over 2 minus 4, and the LCM is 2, 5 minus 8. That will be equal to 5 minus 8 minus 3 over 2. So it is obvious that our common difference is equal to minus 3 over 2. After we have gotten our common difference, we have the value of our first term, we have the value of our common difference. Now, I think we can go ahead to solve the 25th term. To find the 25th term, S25 now will be equal to, according to the formula we have, which is sum of n term, Sn is n over 2 into bracket 2a plus n minus 1 into bracket of d. So I want to insert those values inside this formula. Now, this is 25 over 2 into 2 multiplied by, what is the first term? That is 11 over 2 plus n minus 1, 25 minus 1 into bracket of common difference is minus 3 over 2. So we have the 25th term now to be equal to, we can leave it like this, 25 over 2 into bracket of, that is what, 22. This one we can cut it to make it 11 plus 25 minus 1, that is equal to 24 multiplied by minus 3 over 2. I can cut this one to have what here? 1, 2. 1, 2, that's going to be what? S25 now will be equal to 25 over 2 into bracket of 11 plus 12 times minus 3, that will be equal to minus 36. Now, 25 over 2, 11 minus 36. So now, in this case, we are going to subtract 36 from 11. 36, well, from 11 we have 25 minus 25. 25 over 2. So, will now be equal to, this one will give us minus 625 over 2, which is going to give us minus 625 divided by 2 is going to be what? Minus 312.5. That is the sum of the 25th term of this expression that is given to us here. I hope you are going to stay tuned for the next set of. In this question we have here, we are given the sum of the 16th term and sum of the 9th term. We are asked to find the 38th term sum. We are not provided with the first term, which is A, neither we are provided with the common difference as well. So this is how we are going to solve this kind of equation. You have to have at the back of your mind this formula for the sum of nth term, which is given to be n over 2, 2a plus n minus 1 into bracket of d. This is the formula for the sum of nth term. Now, from this formula now, according to the question given to us, I can be able to deduce the value of this sum of the 16th term and sum of the 9th term. For the 16th term, I can say S16 is equal to 16 over 2 to bracket 2a, because we are not given the value of our first term, plus 16 minus 1 to bracket of d. That one is given to be equal to minus 504. That one has been given to us from the question. And we have the sum of the 9th term, which is equal to 9 over 2, 2a plus 9 minus 1, the bracket of d, is equal to minus 1 to 6. That is minus 1 to 6. So I can now be able to bring this equation out separately to be 16 divided by 2, that's 8, is equal to 8 into bracket of 2a plus 15d is equal to minus 504. We call this equation 1. We also have 4.5, because when you divide 9 by 2, you get 4.5 into 2a plus 8d is equal to minus 1 to 6. We call this equation 2. Now, for me to be able to simplify these equations proper, you can see that it has turned into a simultaneous equation, which I have to apply the method of solving simultaneous equation to approach this. Either I make use of elimination method or I make use of substitution method. But I think the best method I should approach here, or use to approach this kind of equation, is to make use of elimination method. But before then, the value that we have outside this bracket here, they need to be eliminated first, which means that you have to divide both sides by the value we have outside the bracket here. It says divide both sides by value outside bracket at the left hand side. So we are having it to become 8 over 8 into bracket 2a plus 15d is equal to minus 504 over 8. That is for this equation 1. Then you have the 4.5 over 4.5 into bracket 2a plus 8d is equal to minus 126 all over 4.5. This is equation 2. Now, this one we call this one, making this one to remain only 2a plus 15d is equal to minus 504 divided by 8 will give us, or minus 504 divided by 8 will give us minus 63. While this one too, this one called this, we're having 2a plus 8d is equal to minus 126 divided by 4.5 will give us minus 28. Minus 28. Now, this is a very good, this is equation 1 as well. This equation, let's call this one equation 3 now. This one equation 4. Now, for us to apply our elimination method of solving the simultaneous equation to these two equations 3 and 4 now, you can now say subtract equation 4 from 3. Subtract equation 4 from equation 3. So anything we have here will be separated from this equation 3 here. 2a minus 2a, that is, they are the same value, that will give us 0. 8d subtracted from 15d, that will give us 7d is equal to minus 28 subtracted from minus 63. That will be equal to minus 63d minus 28. Minus 63 minus 28 will give us minus 35. Now, I haven't got it this way now, so we can now say that we divide both sides by the common, the coefficient of this difference here. 7d over 7 is equal to minus 35 over 7, where d will be equal to, this one called this, minus 5. That is the value of the common difference for this equation. Now, we have been able to achieve one particular things now, which is what? We have been able to get the value of our common difference. We need to find the value of our first term as well, so that we'll be able to find the sum of the term we are asked to find. For us to find the value of our first term, we say substitute. We can now say substitute this. We have been able to get the value of common difference. Substitute. We now look at any of this equation here. Take any one of them. Substitute minus 5 for d in equation. Let's make use of equation 3. Equation 3. So we are having 2a plus this is what? 15d is equal to what? Minus 63. 2a plus 16d is equal to minus 63. We are having 2a plus 15 multiplied by minus 5 is equal to minus 63. 2a plus minus 75, because 15 times minus 5 will give us minus 75 is equal to minus 63. This is 2a. Plus size minus is minus 75. It's equal to minus 63. Then we can also say that 2a is equal to minus 63. When this one comes in, that negative sign becomes positive, plus 75. It becomes minus 63 plus 75. We give us minus 63 plus 75 will give us 12. 2a is equal to 12. So for us to find the value of our a, we divide both sides by 2. 2a over 2 is equal to 12 over 2, which will give us, this one called this, a is equal to 12 divided by 2 is equal to 6. So it means that our first term is equal to 6, while our common difference is equal to minus 5. We are asked to find the sum of the 30 term. It will be easier for us now because we have been able to get the first term and the common difference. For the 30th term, 30, sum of the 30th term, that is 30 over 2 into bracket 2 multiplied by 6 now, because it is 2a. So that is the first term, 2a plus n minus 1, 30 minus 1 into bracket of common difference is minus 5. So we have in that one to be equal to 15 into bracket 2 times 6 is 12 plus 29 times minus 5 is equal to 15 into bracket 12. 29 times 5 will give us 29 times 5 will give us minus 145. This is plus here. So it becomes 15 into bracket 12 minus 145, because plus times minus will give us minus 12 times minus 145 will give us minus 133. It becomes 15 into minus 133. So now when we now multiply this and this, because this bracket means multiplication, we are going to have minus 1995 minus 1995. That is a sum of the 38 term that we have to find. So these are the steps you are going to take in solving a kind of question like this. It can lead to simultaneous equation. Depends on the way the question is given to you. Just use that question given to you. Use that transformation into bring it into the form of this nation like this. Statement we have here says that the sum of 3 consecutive terms of an arithmetic progression is equal to 6, while their product is equal to minus 90. Now, these terms are not given to us. They say 3 consecutive terms. When they say consecutive terms, it means those terms follow one another accordingly. If you have 1 followed by 2 followed by 3, you have 4 followed by 5 followed by 6, they are consecutive terms. That is what it means by consecutive. Now, so which means that we can have the terms to be in this way. The first term of arithmetic progression is given to us as A. The second term is A plus D, and the third term is A plus 2D. We can have the term this way, that is first, second, third. Now, if you have this term this way, if you add it together and you also multiply it, you'll not be able to achieve the right answer that we are asked to find for this particular question. We are asked to find the terms. Now, if we have this A minus D, take it as the first term, A and A plus D. You can see that they are also consecutive. They follow one another in the right order. So this is the first, second, and third now, according to what we have here right now. If you have this together and you do the multiplication, we can be able to achieve our right answer. So let's look at the way we are going to solve this now. Now, for the sum now. Sum of terms has been given to us to be equal to that. When we add it together, they say it's equal to 6. You cannot say A minus D plus A plus A plus D is equal to 6. So let's collect the like terms. We have A plus A. This is another A plus A minus D plus D is equal to 6. A plus A plus A, that's 3A minus D plus D will give us 0 is equal to 6. So for us to find the value of A here, you say divide both sides by 3. That's the coefficient of A. 3A over 3 is equal to 6 over 3, where A will be equal to 2. We'll be able to find the value of A. Now, you can see the reason why we make use of this set of terms. We make use of these terms purposely for us to be able to eliminate the common difference here out, so that we can be able to achieve the purpose of getting the value of our first term, which is A. Now, we've been able to get our first term now. We want to get the value of our common difference. You cannot say you want to insert a into this particular first equation here to get our common difference. But let's look at the product of the value, because we are also told that their product is equal to minus 90. Now, let's look at the product of this value now. As a minus d, product of those terms, a plus d is equal to minus 90. Now, so what is the value of a? 2 minus d, 2 plus d is equal to minus 90. So we can say that divide both sides by 2. Because all these are multiplied by one another, we can have 2 minus d, 2 plus d. They are multiplied with one another, over 2 is equal to minus 90 over 2. This one can call this out. We're making this 2 to remain in the equation here. Minus 90 over 2 become minus 45. We are having 2 minus d, 2 plus d is equal to minus 45. Now, let's open up this bracket now. 2 times 2, 4. 2 times plus d plus 2d, minus d times 2 minus 2d, minus d times plus d minus d squared is equal to minus 45. Plus 2d minus 2d, we cancel one another out. We are having behind 4 minus d squared is equal to minus 45. Now from here now, we can now say that, okay, what is that? This here? Plus 4. Now subtract 4 from both sides. We are having 4 minus 4 minus d squared is equal to minus 45 minus 4. We are having 4 minus 4, we cancel each other out to become 0. Minus d squared is equal to minus 49. Now divide both sides by minus 1. We have d now will be equal to 49. D squared is equal to 49. So that's when you divide both sides by minus 1. It will cancel those negative values out. So we're having now, for us to find the value of d itself, we have to find the square root of both sides. Find the square root of both sides. You're having d squared square root is equal to square root of 49. So we're having d is equal to, what's the square root of 49? That is 7. The square root of 49 is 7. That is not the end of the question given to us. We are asked to find those terms. So those terms are, you can see the first term is a minus d. That is 2 minus 7. That is 2 minus 7, comma, 2. And the third term is what? A plus d. That is what? 2 plus 7. Giving us those terms to be equal to 2 minus 7 is minus 5, 2, and 9. These are the terms that are provided to us with this sum and their product being equal to minus 90. Question we have here asks us to find how many terms of the series will be summed up to 155. Look at what we have here. We are having the series arrangement here. You can see they are added to one another. That is the series arrangement, which is what? The addition of sequence terms. Now, we are asked to provide the number of terms that its sum will be equal to 155. Now, we have been given the value of our first term. A here, that is the first term, has been given to us to be equal to 2. Why the common difference, which from the expression given to us here is going to be equal to, the common difference is the second term subtracted from it, the first term, or the second term subtracted from the third term. We are going to have the same value. So if you look at it very well, you say 2 from 5, that will be going to give us 3. Also 5 from 8 will also give us 3. So the common difference is given to be 3. Look at the terms given to us. What do we do to get the common difference? We subtracted the previous term from the latest one. That is the second term, you subtract from it first term. The third term, subtract from it second term. They must be equal value. The value must be equal to one another. If not, then that is not an arithmetic progression. So we go ahead in solving this. So the sum of the terms has been given to us, but we do not know the term itself. So sum of n term is equal to what? N over 2. That is the formula for n term. Sum of n term, 2a plus n minus 1 into bracket of d. So we're having sum of n term is equal to, which has been given to us, yes, has been given to us 155 is equal to n over 2. We do not know the n already, into bracket 2a, 2 times a is 2, 2 times 2 plus n minus 1 into bracket of 3. That is a common difference. So we are having it to become 155 is equal to n over 2 into bracket of 4 plus, let's open up this bracket, 3 times n, 3n, 3 times minus 1 minus 3. Put it in bracket. Why do I put it in bracket back? Is because of this positive sign here. Let's assume this is a negative sign. It's going to have effect on the two of them. But if you do not put the bracket there, the effect of negative sign will only affect this, will not affect, which is going to make your answer not to be correct. So you have to be careful when you are dealing with the values that are inside the bracket like this, if it's more than one term. Now, we go ahead, 155 is equal to n over 2 to bracket. You can now open up this bracket, 4 plus 3n minus 3. If you look at it very well, this plus 4 and minus 3 are like terms. You can say 4 minus 3, that's going to be equal to 1. 155 is equal to n over 2. That is going to be equal to 1 plus 3n. Now, this 1 plus 3n is multiplied by n here. So let's multiply it by n. It's the same thing as over 1. This bracket here means multiplication. When you have fraction being multiplied with one another, you know that the numerator will multiply with numerator and the denominator will multiply with denominator. So we are having 155 is equal to n times 1, n plus n times 3n, 3n squared all over 2 times 1 is 2. At this stage, we can now say we should cross multiply because we are having the single term at the right hand side and a single term at the left hand side. This one is as well equal to over 1. So we can now say cross multiply. We are having 2 multiplied by 155 is equal to n plus 3n squared. N plus 3n squared. 2 multiplied by 155 will give us 310. Will give us 310 is equal to n plus 3n squared. Now, look at this equation that we have here now. You have to bring them to the left hand side, all of them. So you're having this n 3n squared will come here because minus 3n squared minus n plus 310 is equal to 0. Now, looking at this very well, you discover that this negative sign here, we need to eliminate it for easy solving of this problem. So let's, by trying to eliminate it, we can multiply through by minus 1. So here we multiply by minus 1, will give us 3n squared. It become positive. When we multiply this one too by minus 1, we become plus n. When multiply this by minus 1, we give us minus 310 is equal to, multiply this by minus 1, we give us 0. It's solved. Now, you can see that this equation has turned into a quadratic equation because of this square here. Now, how do we solve quadratic equation? You can either apply factorization method to solve it, or you make use of completed square method or the formula method. But I'm going to make use of factorization method to solve this now. By making use of that, I'll multiply this by this first. I have 310 minus 310 multiplied by 3n squared will give us minus 930n squared. Now, minus 930 n squared. Now, I'm going to look for two values that when I multiply the two values together, I will get minus 930 n squared. And when I add it together, I will get plus n. So those two values that I'm going to make use of must be different by just 1. So I'm going to make use of 31 and 30. If you multiply 31 multiplied by 30, you will get 3930. But when you add it together, which one will have negative sign? That is the one that is lower in value. So I can now say 3n squared minus 30n plus 31n minus 310 is equal to 0. I make use of this arrangement like this so that you'll be able to relate with one another with ease. So what is the common term within these two terms now? We have 3 can be divided by this, 3 can as well go here. N is here, 3n into bracket. 3n squared divided by 3n, it will remain only n. Minus 30n divided by 3n. N will cut n out. 30 divided by 3 will be minus 10. What is the common value here? We are having 31 is here, 310 is here. 31 can go in 310. I can now have plus 31 into bracket. 31n divided by 31, that will be n. Minus 310 divided by 31 will give us minus 10 is equal to 0. Now, we've been able to solve this equation very well. Why? Because the value we have in this first bracket here is as well equal to the value we have in the second bracket here. If it is not the same, then our factorization method of solving that quadratic equation needs to be checked. So this one is well solved. So we can go ahead. Now we take the value that are not inside the bracket, put them in one bracket, 3n plus 31, and the value inside the bracket, n minus 10 is equal to 0. So 3n minus plus 31 is equal to 0. So 3n will be equal to minus 31. N will be equal to what? Minus 31 over 3. Or n minus 10 is equal to 0. N will be equal to plus 10. Now, number of terms cannot come in negative value. So the number of terms is 10. The number of terms is 10. So this is the number of terms that we are going to add together to get 155. I need to check whether what I'm doing is correct or not. Okay, check here now. I want to check it here. If I put 10 terms there, that will be sum of terms that will be equal to 155. I've gotten that's n over 2. Sum of 10 terms now is equal to 10 over 2 into bracket over 2 times 2, 2a plus n minus 1, that's 9. D is what? 3. That's equal to 10 over 2 is 5 into bracket over 4 plus 9 times 3, 27. That's 31. 10 over 2 is 5. 4 plus 27. That will be equal to 31. 31 times 5 will be equal to 155. So checking has been able to give us the value that yes, this is the right value for the answer. The number of terms that will make up this sum to be equal to 155 is the 10 terms. Thanks for taking part of this class. Do stay tuned for this question we have here. We are asked to find the sum of multiple of 3 between 100 and 301. Now, if you look at the question very well, we have 100 to 301. Ordinarily, if you look at the numbers that we find in between this particular figure given to us, we are going to find about 201 numbers. But in this case of multiple 3, we are only considered about the multiples of 3, those numbers that can be multiplied by 3. Now, if you multiply any number by 3, you cannot get 100. If you multiply any number by 3, you cannot get 101. The first number you are going to have there is going to be 102, which is 34 multiplied by 3. So the first number is equal to 102. If I want to start looking at each of the number one after the other, I will say the next one after will be 105, and that's going to consume my time. Then what I'll do next is to look for the last number. Ordinarily, it is obvious that if I multiply any number by 3, I cannot get 301. So definitely, I cannot go beyond 301 because I'm asked to find the number of multiples of 3 in between 100 and 301. So the next number obviously is going to be 300, which is going to be 3 multiplied by 100. So the last number is equal to 300. Now, that is the number that we can find between this is the first number and this is the last number. We can only pick those two numbers. From that, we are going to know the numbers of multiple of 3. Those values that can multiply by 3, we will know the numbers of which they occur there. Now, for us to find the sum, we need to first of all find the numbers of those multiple of 3. After we have found the number of the multiple of 3, that is when we can now calculate the sum of all those numbers. Now, how do we go about it? Let's look at how we find the number of multiple of 3. How many of this type occur between 100 and 301? Now, this is how you do that. You now say the last number minus first number all over the multiple that we are talking about plus 1. So this is going to give us 300 minus 102 over 3 plus 1, which is going to give us this 300 minus 102. We are going to have divided by 3. We are going to have 6 plus 1 will give us 67 numbers. So now we are going to have 67 numbers of multiple of 3 between 100 and 101. If you check it very well, that is what you are going to get here. 367 numbers. Now, the next thing you now do, we only get the numbers here, but we are asked to find the sum of all those numbers. It is going to be cumbersome for us to start writing those numbers one after the other. So for us to find the sum of all those numbers, we will now say 67, that is going to be the number that we have, number over 2, into bracket, open a bracket for it, first number plus last number. And now what is the number that I found in between them? That's 67 number over 2 into bracket of first number plus last number. That's what 102 plus 300. So if we are going to calculate that one all together, we are going to have 13,467. So that is the sum of the number of multiple of 3 between 100 and 301. Take your calculator to do the checking of all this. Take your calculator, do the checking here, and you'll get the answer in that order. Thanks for taking part of this class. We implore you to subscribe to this channel